Today is going to be 72-1 and we're going to be solving rational equations. And so today's objective, we're going to go through and take a look at a few rational equations and solve them. Now, when solving a rational equation, for the most part, it's just like solving any other equation. But one thing, or at least a theme that you've seen in our other rational equations, is the fact that we have domain restrictions. We have undefined values. And so when I find my solutions, I have to pay attention to what those domain restrictions are. Now, when we do find a solution and it does not work because of the domain restriction, we call that an extraneous solution. All right, first example here. For us to solve a rational equation like this, the biggest thing that we need to do is we need to clear the denominators. We got to get rid of them. So I'm going to rewrite this. So I have x cubed minus 2x plus 1 all over x minus 1. And this is going to equal, and I'll write it as x over 2 and then minus 1. Now I have this x minus 1 in the denominator here. So to be able to clear that out of the denominator, I'm going to multiply everything by x minus 1. Now it clears out of the denominator here. And so it's gone. So that so far is gone out of the denominator. The next thing is I have this 2 in the denominator. So to get rid of that out of the denominator, I want to multiply everything by 2. Now right here, that's going to cancel out. So it's kind of messy, but rewriting what I have, if I were to distribute this 2 through, I get 2x cubed minus 4x plus 2. And then distributing that x through, I do get x squared minus x. And then if I distribute that 2 through, I get negative 2x minus 2. And then so distributing that negative through, I get minus 2x plus 2. So now this looks like a polynomial. And we've learned various ways to solve polynomials. The way I can recognize it, because I have like something x cubed. And so when we solved our polynomials, we brought everything to one side, we had it equal to 0. And then we tried to factor it, maybe there's a GCF or something, and then we did our P's over Q's. And so we're going to do the same thing here. So I want to bring that x squared over. Well, nothing combines with that. I can add x. I can add 2x. And I could subtract 2. So now writing what I have here, these will all cancel out, so I do get 0. I'm going to have 2x cubed minus x squared. Negative 4 plus x is negative 3 plus 2, so minus x, and the 2's cancel out. And so, like I said, I know that that is going to equal 0. Well, trying to factor it, there's an x in common, so I can factor out an x everywhere. So I get x, and then I'm left with 2x squared minus x minus 1, and that equals 0. And now trying to factor this further, this would factor into 2x, x, 1, and 1, and it looks like it's going to be a minus 1 and a plus 1 there. Now because we're solving, remember the zero product principle means that I set each of these equal to 0. Now if I solve for each one of those, I do get x equals 0, negative 1/2, and positive 1. So those are my solutions, but remember, we said that there might be domain restrictions. And so if there are domain restrictions, they can't be representative as part of our solution. So I have to go through and check these. If I plug in 0, am I going to get an undefined value? The answer is no. If I plug in negative 1/2, do I get an undefined value? Well, I get negative 3/2 in the denominator. That's not undefined. If I plug in 1, I get 1 minus 1, which is 0. And so because of this 1 here, I'm dividing by 0. We can't do that. And so therefore, this cannot be a representative solution. So 0 and negative 1/2 are our only remaining solutions that work. Taking a look at example number 2, once again I have to clear the denominator, and so I can clear the denominator by multiplying both sides by what the denominator is. So the x squared plus 1's do cancel out, and so I get 3x minus 1 equals, and then I get x squared plus 1. Well, it looks like a polynomial because I see x squared. More specifically, it's a quadratic equation. So that means I can try and factor it. Factoring doesn't work, then I can go ahead and use the quadratic formula. So let's bring it all the other stuff over, and we can set it equal to 0. So I get 0 equals x squared minus 3x plus 2. And so now I can try and factor this. So x and x, you see 2 and 1, they both have to be negative to get that negative 3. So that means x is going to equal 2 and positive 1. So like I said, I want to check for extraneous solutions. So I should take these values and plug them back in. So if I plug in 2, well, if I plug in 2, I'm not dividing by 0. And even more, if I plug in 2, I get 5 in the denominator. Well, 6 minus 1 is also 5. So 5 over 5 gives me 1. If I plug in 1, I don't get a 1 or 0 in the denominator. But if I plug in 1, 3 minus 1 is 2. 1 squared is 1 plus 1 is 2. 2 over 2 also gives me 1. And so these two values work and for my equation above. So looking at another one. This one has x plus 1 in the denominator. And so to get rid of that x plus 1, you multiply everything by x plus 1. So it does cancel out. And so I get 2x plus 17 equals, now I have to FOIL that through. So x squared plus 5x and 1x, so plus 6x, and then it's plus 5. So now bringing everything over to one side, minus 2x minus 17. I get 0 equals x squared plus 4x minus 12. So now trying to factor this, I'm going to get x plus 6 and x minus 2, which is going to be negative 6 and positive 2. Now checking for extraneous solutions, if I take those values and plug them in, if I plug in negative 6, I don't divide by 0. If I plug in 2, I don't divide by 0. So those are good solutions. On this last one here, I have to multiply both sides by what's in the denominator. So x cubed plus x squared minus 2x. X cubed plus x squared minus 2x. And so those factors will cancel out. So I get x squared minus 2x plus 1 equals x cubed plus x squared minus 2x. Well, if I subtract x squareds on both sides, those cancel out. If I add 2x's to both sides, those cancel out. And so I'm actually left with 1 equals x cubed. So I can take the cube root to both sides to be able to solve for it, and so I get 1 equals x. So if I take that value and I plug it back in, I get 1 plus 1 minus 2. Wait, 2 minus 2. That gives me a 0 in the denominator. So that means that this is not a representative solution, and so I have no solution. There's no value for x that makes that equation true. So this does conclude our lesson. If you do have any other questions, please leave them in the comments.